This lesson will discuss graphing lines in standard form. The first example we're going to look at is writing the equation back in slope-intercept form and then graphing. So slope-intercept form, you'll be reminded that it is y equals mx plus b, where m equals the slope and b is the y-intercept. So to write an equation that is not written in slope-intercept form means we have to solve it for y. I have to get this y by itself. So to do that, I follow my solving equation steps where I subtract 3x, move it all the way over. So I have 2y equals, I can't combine 6 minus 3x, so I put the x in front, negative 3x, and that's a positive 6. Now to get y by itself, I need to divide everything in the problem by 2. So my answer becomes y equals negative 3 over 2x plus 3. So now I can plot the y-intercept at 3. And the slope is negative 3 over 2, so it's down 3 over 2. Down 3 over 2. I repeat, I go on the other side, I go up 3 to the left 2, up 3 to the left 2, and there is my line. Currently, that's how we know how to graph. Standard form, there is a method that might be a little bit faster to graph. In what we call standard form, that is where we have ax plus by equals c, where a, b, and c are numbers, just like how our example started the previous screen. It was, what did we have? It was 3x plus 2y equaled 6. A in this case is 3, B is in the position of 2, and C is our 6. So when it's in standard form, we have the x-intercept and the y-intercept. The x-intercept is when we take C divided by A. Take those two numbers, that plots the x-intercept, in which we get a number here, and the y value is 0. To find the y-intercept, that is when we take C and divide it by B. And that would give us where the x value is 0 and the y value is some number. Let's take a peek at an example. So it says find the intercepts of 2x plus 3y equals 12 and then graph the line. So our standard form says that we have ax plus by equals c. So in this case, my a is 2, b is 3, c is 12. So to find the y-intercept, I'm going to take c divided by b to find the y-intercept. So our c is 12 divided by b equals 3. My y-intercept is going to be 4. So the point that I'm going to plot is going to be the x is 0 and the y is 4. So I can plot that right now. 0, 4 is right here. Now I need to find the x-intercept. Well, the x-intercept is c divided by a, which is 12 divided by 2. I get 6. So the x value is 6 and the y value is 0 because it's the intercept. So remember that my line that goes up and down, that's my y-axis. Left and right, that's our x-axis. So the point 6, 0 is the other point I'm going to plot. That is sitting right here. And now I can plot my line. Put arrows on the end of it. So now we can make a line that goes straight through both points. And we can have our line go directly through these points all the way through the graph. So we find the x-intercept, we find the y-intercept, plot them both, and it takes 2 points to connect the line. Now be mindful, I see this mistake a lot, where people will plot the x is 6, the y is 4. They'll plot this point right here, 6, 4, and say, okay, what else do I do? Well, you need 2 points to make a line. The x-intercept is 1 point, the y-intercept is the other point, and that is where we connect them. We can't combine them and put them together. That doesn't exist. Let's try one more example for you. So again, we have A is 6, B in this case is -3, and C equals 24. So if I want to find the y-intercept, I'm going to take C divided by B, which is 24 divided by -3, which is -8. And then I need to take C divided by A to get the x-intercept. So 24 divided by 6 equals 4. So my y-intercept, the x value is 0, the y value is -8, so it's the point 0, -8. The x-intercept, the x value is 4, the y value is 0, so it's the point 4, 0. So I'm going to plot 4, 0 there. Take my red pen, plot 0, -8. And then with a straight edge, my line's not very straight, I can connect the points to go through the line. I'm going to redo that. And you can pretend that they are connected.